Hello friends, this is Deobroto. Welcome to all of our channel Schrödinger's cat. So now our first lecture is that play with the graphs. Now before going the topic method of mathematical physics, this is our introduction and helpful for all the examinations like IIT JAM, JEST, NET, GATE, SET, TIFR and PhD interview also. This is very important. So our introduction class will be based on the play with the graphs. So for this we have three main topics. First one is introduction of graphs, curvature and transformation, curve tracing, algebraic. We have two functions, algebraic and another transcendental. Algebraic one, there are polynomials, rational, irrational, piecewise like mod function, box function, and otherwise the many forms like that trigonometric, exponential, logarithmic, and it is also known as the inverse of exponential also, and geometric and otherwise the inverse trigonometric. So we now first go through for the some polynomial graphs. For that, here we now just learn for the general form like fx x to the power 2n, where n belongs to capital N, because after getting through this knowledge we now deduce the x square, x cubed, x to the power 4 dot 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 etc. For this we have some basics of class 12, that the domain and the range of a function. So first of all, two sets, that we have x to the power 2n and otherwise x to the power 2n plus 1 or 2n plus minus 1. First one is even function and second one is odd function. Even function is symmetric about y-axis and odd function is symmetric about opposite quadrant, that means symmetric about origin. So getting this concept, we now deduced first one x to the power 2n. Its range belongs to x belongs to minus infinity, minus 1, union 1, infinity. This is range and also the domain. So for drawing this, we have two axes. This is 0 x and y, and its range lie on the minus 1 to 1. So this is our y equal to x, and this is x square, this is y equal to x, and this is x to the power 4. In general, in this way, we now trace the general graph x to the power 2n. Now our second one, x to the power 2n minus 1. For this we have same concept here for the range and the domain of polynomial equation. For that we just try here this is our 0, x and y, and y equal to x, and after we see our range -1 to 1. So this is our x cube, and this is our x to the power 5. So in this way we now generally reduce in general form x to the power 2n plus minus 1. So now next to our second category, that the rational graphs. So we have to deduce the rational graphs like that for such a case that fx one by x to the power 2n and another one by x to the power 2n minus 1. So first of all, for x to the power 1 by 2n minus 1, we assume that this is an odd function and its graphs should be symmetric in opposite direction or opposite quadrant, that is called the symmetric about the origin. And here we concept that for y equal to infinity, limit x tends to 0 plus fx, and y equal to minus infinity, limit x tends to 0 minus fx. And we now draw this is 0, x and y. This is one quadrant and another, and it is y equal to 1 by x. So in general form, x to the power 2n minus 1, that just bend like that. Here I am using writing pad, so my graph plotting is not exact, and you also just go through in your pen paper and it will better for you. And this is our y equal to 1 by x cube. For simplicity, in this case we now deduce 1 by x cube, 1 by x to the power 5 and dot 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 1 by x to the power 2n minus 1. Next, coming to the other part, that fx 1 by x to the power 2n, this is even function, so now it is symmetric about y axis. So just plot this is 0, x and y. So this is our 1 by x square, and for drawing this is our 1 by x to the power 4, and in this way, and also its range lie on the -1 to 1. In this way we just plotting the graph of rational functions. And after our third category is that the irrational functions. Irrational functions like 1 by, in case of 1 by x we have the x to the power half or x to the power 1/3, like that, are TIONL, irrational functions. So come to the other point, that for the irrational functions we now go through two functions like fx x to the power 1 by 2n and another one x to the power 1 by 2n plus minus 1. So for x to the power 1 by 2n, that means here all the domain and the range x belongs to 0 to infinity. You just go through the domain and range of a function in the class 12. So here we now just accepting this fact, and you also just checking it. This is our domain and range, and in this way we now plot this graph. That this is our y equal to x, straight line passing through origin, and this is y equal to x, y equal to x square, and for drawing x to the power half we just see that here same case happen. This is our x to the power half, and the another way this is our x to the power 1 by 4. So in that case we just now trying the another one, that is x to the power 1 by 2n minus 1. For that we have 0, x and y, and in such a case that we have same case y equal to x, straight line passing through origin, and we have the y equal to x cube x to the power 5 and so on. Same case happened that this is our actual y equal to x to the power 1/3 and x to the power 1 by 5 and dot 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 so on x to the power 1 by 2n minus 1, and this is our, in this case this is drawing here the even function and this is for the odd function dot 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 x to the power 1 by 2n minus 1. And we just now after go through the our fourth one, that the piecewise function piecwise. Nice. Okay, fine. We have piecewise function like that, and we have several terms. In that of case, first one is mod function, y equal to mod x. So we just know mod x, define x greater than equal to 0 minus x less than equal to 0. So we have just plot here minus x and this is x. And one more thing is that its range belongs to 0 to infinity. And our next one is signum function. So y equal to sgnx, signum function, and this is the definition y equal to mod x by x or x by mod x, otherwise 0. For that x not equal to 0 and x equal to 0, two case we have three part. 1 x greater than 0, minus 1 x less than 0, and the final one 0 when x equal to 0. And his domain D R, so this is real number, and the range lie between minus 1 and 1. So we now just plot here, this is our 0 x and y, and range is almost 1 to minus 1, and this is 1 and that is another. This is our graph for signum function. So now just another one, this is 1, this is 2 and this is 3, that greatest integer function or stepwise function or floor of x, we now conclude box x. So box x is defined by 0 less than equal to x less than 1, 1 less than equal to x less than 2. So minus 1 in the same case, minus 1 less than equal to x less than 0, minus 2 dot dot dot. So we just now draw here that this is our x axis and y 0 or origin O, x and y, and we just conclude that here 1 2 3 and for here also we just now positive direction and also other, and this graph would like be that this 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 and for such cases we that this one, this one and this one. This is our box 6, and the another one, that is number 4, that is the fractional part of function. It is defined at second bracket in the x, that is x fraction means x 0 less than equal to x by define, and the another x minus 1, this is fraction 1 less than equal to x less than 2, and another one x plus 1, so basically it may be minus 1 less than equal to x less than 0. So for plotting this we have draw two section O, and this is x and y. So basically this is 1, and the graph would like to see that, and this is 1 2 3, and it would like that this is the graph look like that. Just see, this is the graph of the fractional part of function, and we have the another one, the last part. Here we just list integer function small x just minus 1 0 1, for 0 minus 1 less than x less than equal to 0, 1 0 less than x less than equal to 1, and for minus 1 this may minus 2 less than equal to x less than equal to minus 1, and this is the same as the box x. So you just try and check, and homework for you, this is the same as the box x. So now going to the another one, this is the another part, and it is the transcendental functions, so that the we now conclude that SCDNTAL transcendental function. So here we have, you also familiar with these equations like y equal to sin x, cos x, tan x, cosec x, sec x and cot x, and you also familiar. So we now just leave it but and try to explain the inverse of this, and we just write some of the, because the sin x is range lie on the minus 1 to 1, and the tan x this is basically the range R belongs to minus infinity to infinity, and the sec x it also range lie on the minus 1 to 1, but is the closed interval. It is the, so this is our the topic, and we now go through the some exponential functions like exponential function like fx a to the power x, where domain, we also find first of domain and range. Domain belongs to real number and r belongs to 0 to infinity. So for plotting this graph, we just taking here the two sections. This is origin and x and y, and for this case we just firstly find to the graph, and we just now see here the increasing order and the decreasing order also, and the our main graph is also like that. For this is your a1, this is a1, and this is another one, and in this way we just, this is another, and that is another one. So this is our 2 to the power x, 3 to the power x, 4 to the power x, and the exponential graph would like to show as the in the figure. So we now just coming the another one, the logarithmic function. Here we just plot that y equal to a to the power x or x equal to log y. Here we have seen that two graph, like this is the beauty of the graph theory. One is exponentially increasing order, another one is decreasing, and it should be also the 1 0, and this is also same, and this is for the case of a greater than 0 and this is the another one for the 0 less than a less than 1. So we have two separate part, and the another one for the geometrical graph, also straight line, circle, parabola, ellipse, hyperbola, and we just now saying the main of two here. The rectangular hyperbola is equation, follow equation x square minus y square equal to a square, and is shown like that. And the another one xy equal to c square, this is like that. So next we just now another part, the main part, that the inverse trigonometric function. Inverse trigonometric function. So now for this case we just now consider here the y equal to, first of all, y equal to sin inverse x. So for this we also know the sin x, but how we can evaluate the sin inverse x? Basically here same, we have the x range belong -1 to 1, and the domain y belongs to minus pi by 2 and pi by 2. This is the range and the domain of this function. Now our second work to draw this. For this we just now x and the y. So this is our sin x, and this is our sin x, and we have to plot sin inverse x. So basically we just now main concept that the domain and the range we now just plot here. The function like that. This is our actual y equal to sin inverse x, and this is sin inverse x. And home task you for the, you just now draw y equal to cos inverse x for the similar, and we just now show here the graph for the tan inverse x. This is your home task. We now plotting y equal to tan inverse x. So for that plotting, first of all, tan inverse x, the domain belongs to real number and the range lie on the minus pi by 2 to pi by 2. First case we should now deduce the domain and the range of this function in the equation, and now we just draw for these two main concept that so this is our tan x, but how we plot the tan inverse x? This is one and the another one like that. This is our actual y equal to tan inverse x, and this is pi by 2 and minus pi by 2. So in this way you also just plot the cot inverse x. Now coming to the another part, that the sec inverse x, y equal to sec inverse x. So first of all, one more thing, that the domain belongs to, I already told, -1 to 1, and the range 0 to pi by 2. This is domain and the range, and we just plot here. This is our x, is y. This is another part. We have no the sec x, but we trying to plot the sec inverse x. For that, this is our origin, and we just now this is one and another, and this graph should lie between here one and the other. Actually, this is the like that. This is our actual sec inverse x plotting. So now the our main another part, that the trigonometric inequalities. This is another trigonometric inequality. Trigonometric inequalities. So for that we just now say one inequality. This is the main application for drawing any graphs, and I think this is useful many examinations and also interview. So we just now consider an equation for this, like that problem 1 and tan x less than 2. We have to plot this tan x less than 2. So basically its period pi, and check the solution in the interval minus pi by 2 to pi by 2, and we just say that minus pi by 2 less than x less than tan inverse 2, or minus pi by 2 less than x less than arc or amplitude of tan 2. So we have now deduced that we have just explored that we have just know the tan x graph, but we just try to evaluate tan x less than 2. So for this, the general solution of this, that n pi minus pi by 2 less than x less than 2n pi plus tan inverse 2, or in general case we just now n belongs to 2n pi minus pi by 2, 2n minus pi by 2, and the another one 2n pi plus arc tan 2. This is our main 2 part, and we now just drawing. Just we have the x-axis, this is our y. So basically this is y equal to 2, and this is the interval, one is pi by 2 and another one minus pi by 2, and this is the beauty, that we have the graph of tan x like that, this one. So basically one thing I just saying that I just writing the pad, so my diagram is not the right perfect, but you just now drawing in the pen paper, it need to be better for you for understanding. And this is basically the tan x, but here we just plot tan x less than 2. So for that, this is our tan x, but this portion, our x equal to tan inverse 2, that equal to arc of tan 2. So this is our main outcome. So we just show our main graph of the inequality of the trigonometric equation tan x less than 2. We just now consider from here, this is not, this portion should be not, cut out, and our inequality start from this, and this is our the final outcome, tan x less than 2. So in this way you just solve yourself for the home tasks for better understanding. Homework that cos 2x minus sin 2x greater than equal to 0. You just plot this graph and send me for the better understanding in the mail ID given in the description box, that the cat Schrödinger's 1935@gmail.com. You just send me this graph for the better understanding, and we just now move for the another example, that main heading is this problems. So our main task, that problem number 2, y equal to sin inverse sin x. This is very beauty. So we have the function of period, we have no sin x, and after that we have just come to know that the sin inverse x. But how can I draw the graph of y equal to sin inverse sin x? So this is our period t equal to 2 pi, and we just now write here that the sin inverse sin x, this is basically x for range minus pi by 2 x pi by 2, and the another one pi minus x pi by 2 x c pi by 2, and just which is defined for the interval of the length, interval 2 pi. So we now just plot here, this is our x and y, this is our interval, and another one, this is interval pi by 2 minus pi by 2. So just see here that we have, for drawing this graph, this is basically straight line, because here pi minus x, straight line with slope m equal to minus 1 and the range minus pi by 2 pi by 2, and just see here this is one and that is another. So one is increasing, going up, and going down. So basically its graph would like to be a straight line with up and down. We have the slope m minus 1 and interval minus pi by 2 plus pi by 2, and this is going on. So basically this is formally its graph, that it's y equal to x and this is y equal to pi minus x, and this line is x minus 2 pi and that is pi minus x. So this is the actually going up and down is y equal to sin inverse sin x. So in this concept you just plot this graph, and your homework, I think just it is basically the homework number 3, you just sketch the graph tan inverse tan x, and after completing all these problems you just mail me in the given ID, which is in the description box in the YouTube channel name Schrödinger's cat. So this is our one part. So we have now another thing, we have now deduced the sin inverse sin x. Now here we just saying problems 1, and after we just another problem, that problem 2, this is our funny, and the another problem y equal to sin of sin inverse x. First one is sin inverse sin x, but this is sin of sin inverse x. So for y equal to sin of sin inverse x, here we just seeing that domain D, x belongs to minus 1 and 1, and the range y belongs to minus 1 and 1. So basically the minus 1 and 1 are the domain and as well as the range of this equation. So we are saying that y equal to sin of sin inverse x basically comes in the result that y equal to x in the range of y belongs to minus 1 to 1. So we just now plot here, this is our quadrant, this is yes 0 x and y, and that is y equal to 1, and that is y equal to, sorry, this is line parallel to the x-axis, so y equal to 1, this is a line, that line, this is basically x equal to 1. So our main sin of sin inverse x, now basically it is the y equal to x, so the straight line passing through the origin, this is our y equal to sin of sin inverse x. So in this way, one another homework number 4, I think, just you just sketch the graph of the y equal to sec of sec inverse x, you also just plot it, and we just now coming to our next part, basically the next topic is that the curvature and the transforms. So for doing this, we just now second part, curvature and transform. Our we should just conclude problems. Problem number 1 for the second part, curvature and transformations. Curvature and the transformation. So for that, here we just apply of this graph. So first of all, sketch the curve of y equal to x minus 1. This is very important, and this is the most beautiful application of this play with the graph. So we just now sketch the graph of y equal to x minus 1 into x minus 2 into x minus 3. So for plotting this graph, we have just familiar with this three topic. First of all is concavity. Concavity means second order derivative d2y dx2 is greater than 0. Convexity means second order derivative d2y dx2 is less than 0. And last but not the least is basically the point of inflection. The point of inflection is that the second order derivative is equal to 0, but the third order derivative d3y dx3 is not equal to 0. And I just not explain the physical meaning or physics behind it, and just mathematically I just write it for the condition for approaching our sketching the graph. So first of all, for plotting this graph, we have point number 1. We first choose y equal to 0. That means the solution x equal to 1, 2 and the 3. Second thing that we just see are the conditions, and first order derivative dy dx, and this is the equation of x cube minus 6x square plus 11x minus 6. So dy dx equal to 3x square minus 12x plus 11, and the d2y dx2 it would become 6x minus 12. Now we just taking first order derivative should be 0 for the maximum or the minimum condition, and we just solve it, we get this result 6 plus minus root 3 by 3. And after that, for drawing this graph, this is the final that we just put in here y dash, we just get into the here 3x square minus 12x plus 11. C, we just put it as in the asymptote form, x minus x dash, this is our x dash here. So x minus 6 minus root 3 by 3 into x minus 6 plus root 3 by 3. So we get the range in this equation, that 6 minus root 3 by 3 less than x less than 6 plus root 3 by 3. This is the range, and we now deduce the graph from that. And after that, the last what the not the least the condition is that the concave case for the x greater than 2, the graph is increasing, and the x less than 2, the graph is be decreasing order. Because we just now see here for the x value of 2, this is concave, because we just now following here d2 y d2 dx2 greater than 0 for the concave condition, and we just now put here, and we just now get the final two equation, and we just now plotting the graph. So this is our one axis, and that is another one. This is origin x and y. So here it is our maximum range, maximum minimum condition. It is our maximum, it is our minimum, and this value, I think this value would become 1.42 less than x less than 2.58. So here this is a 1, 2 and 3. So the graph should lie between in this range. And we have the another point, that in these two cases, that x less than 2, this is concave and going down, this condition here, and the another one x greater than 2, this is the up. So now we just plot here, and this point is that 6 minus root 3 by 3, this point is that 6 minus root 3 by 3, and this is 6 plus root 3 by 3, and this is our say minus 6. So for drawing this graph, we just conclude here 2 point of inflection is that 6 minus root 3 by 3. So 6 minus, so start from the minus 6. So here we just draw this graph carefully. This is basically a straight line, and in this range the graph should be down here. It is a maximum point. I just another time I just draw here. This is our maximum, and after that the graph should be going down. Just like this is the minimum point, and after that it should be same, follow the path, and this is the point 3. So in that way we now just deduce the graph of the application of curvature and the transformation, and this equation we just now draw here. So for the homework number 5 homework, you just sketch the graph of fx mod x plus 3 into x plus 1. Just sketch the graph and mail me. So our last part for the graph theory, that the curve tracing. Curve tracing. So the curve tracing and the another one we just solve here. This is the application of the graph. So we now just sketch here the curve with the parametric equation x equal to a into theta plus sin theta and y equal to a into 1 plus cos theta, where x belongs to minus pi by 2 থেকে pi. This is our question. Question 3 problem. So for deduce, we just write here the equation x equal to a into theta plus sin theta and the y equal to a into 1 plus cos theta. So we just now a table theta and minus pi 0 pi, here x y. In this two sinusoidal or simultaneous equation, we just put here the minus pi theta, we now get minus a pi and 0. For theta 0, we just here get x0 y2a. For theta pi, x a pi and y0. And we just now here get the range minus pi theta less than equal to 0. And first of all, we just check the concavity, convexity and also such a point of inflection. We just dx d theta a into 1 plus cos theta and the dy d theta, this is basically minus a sin theta. Formally, for this first condition, the ds d theta equal to 0, that is we get the theta pi minus pi, and also we have the tan theta range theta plus minus pi, that x equal to plus minus phi. So basically this is look like this spiral case, and for drawing this graph we just now draw here that x and the y. So this is basically graph of some cases. For that we have tangent at theta equal to pi and minus pi, get result x equal to pi minus pi for this condition. So thus final conclusion is that the curve for these two simultaneous would like to be the starting from the point xy moves to right and down. Starting from move to right and down to the range of the a pi 0 after 0 to a minus a pi 0. We just writing here, that's these conditions, that minus a pi 0 after that 0 to a after that a pi 0. So basically we just plot here this is 0 and this is pi minus pi. So first of all this should be done with range minus pi to pi, and after that this. So in this way, this is our main curve tracing of the simultaneous equation of the parametric x equal to a into theta plus sin theta and y equal to a into 1 plus cos theta. So in that case, you just now deduce, this is our, we just conclude here the parametric equation, and you also now to solve for the homework. I think this is the homework 6, that sketch the graph of the algebraic equation using curve tracing method, that x cube plus y cube equal to 3ax square, a greater than equal to 0. Problem number 6, home task, and you just solve this all these 6 homework for the better understanding and just mail me, and I think this is very helpful for you, and I also write my email ID for your benefit, that cat Schrodinger's Schrodingers 1935. The Schrodinger's cat experiment was done in 1935. So basically the cat Schrodinger's 1935 at the rate gmail.com. You just mail in this ID after solving these 6 homework in your home. So I think this is my first tutorial for the play with the graphs for the benefit of the all examiner and as the interviews. So I just now back after some days for explain you the most important thing in the next exam, the numerical method like Simpson one-third rule, trapezoidal rule, Gauss elimination method, Newton-Raphson method. This is done for the second lecture, and I will back to reveal for this numerical method, and I think this is also very helpful to your entrance exam. So thank you very much. Just thank you all. Goodbye. Stay well and happy. Take care. Thank you. I just ending my lecture here. Thank you. Goodbye. See you after some days. Revealing with the numerical methods CSI and NET aspirants. Thank you.